So I could see why you picked less massive or more massive. Okay. Now I'm going to hide responses. So mass and velocity change are proportional to each other. So this means as one changes, so does the other. Okay, as one changes, so does the other. So as mass changes, velocity changes as well. So for a given force, if the mass is less, the velocity change will be greater. So if you have less mass, the velocity change will be greater. That means that the object can start moving, stop moving, change direction, speed up or slow down quicker, right? If it's less massive. If it is more massive, that means the opposite. Okay, it's going to take longer for that velocity to change. All right, so we have a key concept. Once you put this key concept down in your notebook, you can close your notebook out, and we will not use it for the rest of class. So this key concept says if the same strength force is exerted on two objects, but the objects have different masses, the object with less mass will have a greater change in velocity. So if the same strength force is exerted on two objects, but the objects have different masses, the object with less mass will have a greater change in velocity. I'm going to go ahead and type that in the chat so that you guys can see it. And so what our next activity is going to do is it's going to incorporate the pod mission. Okay, so we talked about a little bit about the wheelchair and how having less mass makes it move quicker, or having more mass won't tip the object over. What we're going to do is we're going to relate the pod mission to what we've just learned about mass and velocity and force. Okay, so make sure you get this key concept down. When you are done, you can exit out of your interactive notebook or your digital notebook. All right, so I've put that in the chat if you're falling behind at all. And so activity 3 is going to be modeling how the same strength force would affect velocity change of a more or less massive pod. Okay? So the thrusters on this pod exerted the same strength force as pods on any other mission. So we know in a regular mission that they would dock at the space station. So instead we found that this pod was moving in the opposite direction. All right, so this was claim 1 and claim 2. You guys have seen this screen quite a bit. Claim 1 said the thrusters caused the pod to move in the opposite direction. Claim 2, the thrusters slowed the pod. It hit the space station and made it bounce in the opposite direction. All right, so this pod's mass is still a question. We don't know how many of those asteroid samples are on this pod. We don't know if it's less massive, more massive, what's going on. And since we know that the same strength force affected this pod differently, something has to be different about the mass, right? It has to be different if this pod did not dock at the space station. All right, so this is a multiple choice question. There's only 2 answers here. All right, so you are trying to determine if in claim 1, whether that pod was more massive or if it was less massive than what it normally is. And then for claim 2, you're trying to decide whether that pod was more massive or less massive than what it usually is. So they are not the same. So claim 1 doesn't have less mass and claim 2 doesn't have less mass. You either have claim 1 has more mass and claim 2 has less mass, or claim 1 has less mass and claim 2 has more mass. All right, so we know something is going on with the mass of each of these claims, but which one is which? Which one has less mass and which one has more mass? right? So ask yourself this question. How could a difference in mass cause this pod to move in the opposite direction? So the thrusters cause the pod to move in the opposite direction. How could the mass affect that? Are you going to have less mass than normal or more mass than normal? And then for claim 2, how could a difference in mass cause the pod to slow down but not stop when the thrusters are fired? So it slowed down and hit the space station. All right, is it less massive or is it more massive than usual? All right, answer that question on Pear Deck. It looks like I got about 7 out of 19 people responding. I will show my responses when I've got most people responding. All right, I need a few more people. Make sure you're answering this question. Think about whether claim 1 is going to have more or less mass in the pod, and if what claim 2 is going to have more or less mass in the pod. If the thrusters are firing in the same way that they always do. All right, please make sure you're responding. Back in Pear Deck. The quicker we respond, the quicker we can move on. I've only got 11 out of 19. I really want to show these responses, but I'm not getting everybody responding. All right, this is what happened last class. There is one right answer and there is one wrong answer here. So we've got to figure it out. Okay, and I think this is where the modeling tool is really going to help us see it and kind of explain it. And so some of you guys are saying that claim 1 had more mass and claim 2 had less mass. Okay, so if that was the case, if claim 1 has more mass, claim 1 says the thrusters cause the pod to move in the opposite direction. If the thrusters are at their normal force, you're telling me that the mass is greater than what it normally is, and the thrusters are going to make it move in the opposite direction. And then claim 2, you're saying that the pod has more mass now and that it's slowing down and it's going to hit the space station. The other people, if you're saying that claim 1 has less mass and claim 2 has more mass, if claim 1 has less mass, the thrusters have caused this pod to move in the opposite direction. If claim 2 has more mass, then that means the thrusters only made it slow down and it hit the space station. Okay, really think about that. Which one has less mass and which one could possibly have more mass? All right, what do we know about something that has less mass? What do we know about the movement of something that has less mass? You guys can respond in the chat. This is what people in last class were having trouble with. Something has less mass. What do we know about it? Okay, Isaiah said it moves faster. Okay, what about the velocity changes if something has less mass? What did we just see in our key concept? Drew says it's easier to push. Less mass makes it easier to change velocity. Perfect, Addison. That is literally exactly what our key concept just said. So I'm going to go back to our key concept. If the same strength force is exerted on two objects, but the objects have different masses, the object with less mass will have a greater change in velocity. The object with less mass will have a greater change in velocity. Okay, so think about this question here. If you think you need to change your answer, for those 7 of you that aren't responding, you need to respond. But really think about that. If something with less mass is easier to push, it moves faster, it changes velocity quicker or easier. Do you think claim 1 has less or more mass? And do you think claim 2 has less or more mass? All right, nobody has changed their answer since I've talked about that. So we are going to leave it at that. This model is going to help us maybe answer this question and figure this out. All right, so you guys will now model the inferences you made for each claim. You're going to show how the pod moving away from the space station could be related to its mass. All right, so this top row shows what usually happens during the missions. Okay, this thing squared off in blue shows what usually happens during the mission. You have a medium force moving a medium mass object. Okay, then you have a medium velocity with a medium mass object. You have a medium force acting against that object to make it stop. So this after force is showing me that it is not moving. Right? What you are going to show is what happens for claim 1 and claim 2 down here at the bottom. So the same strength thruster force was applied to this mission, or was applied to this pod as in other missions, but to either a more massive pod or a less massive pod. Talking too quickly. All right, so what you're going to do is you're going to either drag a less massive or a more massive pod, so a small or large mass pod, into each of these 3 rectangles right here. You are then going to have the same strength force, so you're going to have this medium arrow in the during force. Medium arrow is going in the during force because you know that the same strength thruster force was applied to the pod. We're trying to figure out is it more massive or is it less massive with claim 1 and claim 2? Right, so you're going to be showing both claims. If you want to go ahead and press on the screen, you can. All right, so once you go to this, you're going to show claim 1. And it tells you all of the steps here on Amplify. If you're looking at my screen, it will tell you all the steps that you're going to go through. It's going to tell you your goal, it's going to tell you what to do, and it's going to give you a tip. So the during force panel for this pod should use the same strength, force, and direction of the force as the pod in the first row. All right, so you have 2 circles down here at the bottom. One is going to show that claim 1 chapter 2. The second one is going to show claim 2 chapter 2. So make sure you know which claim is which. If you need to pull up claims 1 and 2 on another screen and kind of go back and forth between those, you can. Or you can just make sure you're paying attention to the goal. So for claim 2, the goal is to model the pod's mass so it shows that the usual thruster force could only slow the pod, not stop it, and cause it to hit the space station. All right? Do those 2 models for me. This happened last class and we did not have time to get to the homework. If you are moving along and you've already done tabs 3 and 4, then that is totally fine. But we are not going to get to the homework today. And you don't have to worry about doing that out of class. So we are going to do that on Wednesday before we watch our video. Because we're going to have a longer video where we're going to take, not notes, but where we're going to answer questions on the video. Okay, so do not worry about tab 4 on the homework. We are going to do that before we do our video on Wednesday. All right, so what you need to do, if you have not done this already, is do these 2 modeling tools, and then you're also going to have an exit slip like normal. All right, so we've got our 2.3 exit slip on Canvas. So once you get done with your modeling tool, you've got this exit slip. If you understand what you're doing and you don't have any questions, then you are free to go. We've got about 4 more minutes, so if anybody wants to stay on here and has any questions on the modeling tool or the exit slip, just let me know. If not, y'all have a great Monday.
Bye.
Bye.
Hey, Miss James.
Yeah.
We're gonna.
Yeah. I emailed them the Zoom link. Yeah. Yeah. Okay. No, that's fine. We can still talk even if it's a short meeting. I know your parents just want to kind of make sure that you're on the right track, but if you're understanding everything and we're good, then it shouldn't be too long of a meeting.
Okay.
All right. Have a good Monday. See ya. Jatavion, Sam, do you guys need any help? You guys good? All right, Jatavion, I'll see you on Wednesday.